Hello everyone, Sean, welcome back to the channel. Sitting in front of me right now is a Sony audiovisual receiver, model number STR-DH590, Sierra Tango Romeo Delta Hotel 590. Supposedly this AV receiver took a lightning strike and no longer turns on. So in this video we're going to diagnose the failure and try to get this repaired. I suppose to start us out, typically I don't just plug things in and try to turn them on myself, but in this case I am going to do it after I take a resistive measurement across our leads. Just kind of want to see if the primary is shorted out on here. And we are getting 560K impedance, which appears to me that this could just be the coils or the windings on the primary tap on our transformer. So I feel fairly confident that I can at least plug this in to my variac and dim bulb tester. Now, if it turns on, it might not stay on because of how current limited it is. But we'll do that and we'll see if we get any kind of visual indication before we start taking this apart and looking at different components. Hey, with the isolation transformer and variac on, drop that down just a smidge. Alright, let's turn on our dim bulb tester. Let's see if we get any life out of this thing whatsoever. Well, we do have a red light. And we've got a green light. And it's saying protect. And turned right back off. Now, it could be because we're on the dim bulb tester, but I didn't see anything light up over here. So what I'm going to do is I'm going to shut this off from here. And I'm just going to come down to here. And let's see if it still says protect. Yeah, still going into protect. Okay. So at this point, I think it's safe to say that we've got an issue with this receiver that we need to check into. So what I'm going to do is unplug it and at minimum see how this thing comes apart, take off the outside of the chassis, and we're going to give it a good visual inspection. Okay. So we've got the chassis off, just several screws. Not a whole lot to that. And what I'm going to do is just take some voltage measurements. Get it plugged in and powered on. So pin 1 here says AC cut. Pin 3 is power standby or power BY. Not too sure. It keeps going into over protection mode. We got 3.1 volts there on that one. Pin 4, we've got our 3.3 volts. Pin 5, we have our 2.2, and it cut back out. Let's turn back on. Pin 6, we have our 4.6 is indicated. Pin 7 should be 6.3, we're pretty much there. And pin 8 should be 2.2, but I don't really think that's the case because, let me unplug it for a second. If we were to check continuity from that pin, which we can actually do from this side over here, that feeds to this pad right here. Okay, but you see there's all these unpopulated components over here, so I don't think that's the case. I don't think there's going to be anything to here, so not positive we're going to get a 2.2 with a whole bunch of unpopulated components. But you know, this is mostly just an inspection for right now. I do kind of want to take a look at this board over here at Power Up using a thermal imager. So give me for a second. Okay, with this thermal imager on, I kind of want to focus on, you can see my finger right there, this main IC and any components over in this area. And let's see if anything gets super hot. Okay, we got several things getting super hot. A few things in this area, I'll try to mark those out. And another thing right down in there. So let me mark those out. Give me one more second. Now, as far as marking everything, I didn't really have a Sharpie marker, so I could just kind of use a red crown. We have this pad right here that's getting super hot, so we'll have to see where that goes through on the other side. And this one right here, we do have a looks like a fuse or a capacitor sitting here. As far as that very hot spot, and I checked with all the other ICs, that very hot spot's coming right off of this IC right here. Now, I do kind of want to unplug it for a second, and I'm going to take and put my red probe on the ground somewhere, and then my black probe is going to be used to check some of these caps surrounding this IC right here. So far, all that is looking perfectly fine. Looks like we got a cap here that might be shorted. Cap here that might be shorted. These are filters. Another cap here that might be shorted. Another cap here that might be shorted. Another one here that might be shorted. And it looks like a little resistor could also be shorted. So we might have some issues on this side of this chip. You know, somewhere in here, short could be, these components could be shorted, or this chip could be bad. Again, hypothetical at this point. We're just capturing data, so to speak. But I can't unplug this or really any of these things and expect it to still power up. As a matter of fact, I'll just show you. Let me just unplug like this cable right here. Obviously there's no power. It's going to detect an issue and it won't even turn on. But yeah, we don't even get a red light with that unhooked. try this one over here. We do get a red light. Do we get any change in condition? No, going back into protect. Let's see. Let's choose the cable that goes to the display. Probably won't turn on without that one. Some clicking, but yeah, now the red light's not even on. It must have been residual power or something, or maybe that feeds the actual display. Maybe that's the data to the display. Alright, let's take out this cable. Anything different with this? Yeah, it turns on. And we are back into protect mode. And it shut itself back off. So, something is still triggering it. Potentially this board right here has had a failure. But I'll have to pull up a data sheet on that. Take a look at those pins. If I can get a data sheet, we might be able to decipher something from that data sheet before we dig any further. So let me see if I can find a data sheet. And just so you're aware, this is a Panasonic. What's the number on this? We can get down there now. It is upside down, so forgive me. MN864788. I realize that is upside down, but that is the part number right there. MN864788. So let me get some information on that guy. Okay, so what I've done is I've removed basically this HDMI board and what feeds to our display on the front. And you know, I'm keeping in mind the short side. See across these capacitors here, that hot spot we have on this Panasonic. There, you can see it better now. MN864788, which I cannot find a data sheet for this, so at least not in the last 20 minutes that I was looking. So I'm just going to leave it be for now. And what I want to do is actually I kind of want to check between these two posts on the other side. And when you flip them over, it is actually this K13 that we have here, WR K13, which should be some form of PMIC or power management IC. Okay, and you see that center pin there, that's going to be the ground corresponding to these two caps. Left and right pin will be some form of voltage in or voltage out, regulated voltage. Now, let me show you what I've discovered. You put it on resistance. We can check across this cap. We have an open across this cap. And we have a short. Almost a direct short. Okay. As a matter of fact, if I put it on continuity, short, no short. If I go from this pin right here, short, no short. Center should be shorted because that should be the ground. So, is it the cap or is it the PMIC? But, you know, even though I don't know that for sure until I remove it, something else we can do is let's go red probe on the positive lead, positive side of this cap, the one that is shorted. And let's just check on the other board, other side of the board, where we had those other shorted components. And can I do all this with it on camera? Not too sure. Yeah, I'm not getting contact on there. Hold on 1 second. All right, now we'll flip it over. And I was probably on the wrong IC there anyways. Yep. And everywhere we got the short before, we're getting it again. So I think, now, I think this is a problem, okay? I don't believe that cap should be shorted. And I don't know if it's the cap or if it's the PMIC, but we can remove the cap and test the pads and make a determination from there. The other thing is, say this is a problem, and say resolving this fixes what we see over here. I don't know if this is the only problem inside this AV receiver, but it's worthwhile at least removing this cap and checking to see if the shorts are gone. So I'm going to get out my hot air station and remove that cap, and we'll see what happens. So I've got that capacitor removed out of here. Got it sitting right here, right there. Let me just move it up to here for a second, and we can see if we're still shorted on the pads, and we are. So next thing I'm going to do is remove the 6-pin IC right here and see if it's gone once that is removed. And reinstall this cap. Resolder that back in. Okay, I have the cap and the PMIC removed. Let's check the pads again. And we still have a short. No short between those 2 points. Okay, so at this point, I think the best thing for me to do is to put this back on and solder a small wire with both those components back in to this lead over here, inject some voltage, and see what heats up on the board. So, I've got a little wire soldered onto one side of that cap. Got my power supply set at 1 volt, and let me turn off the light here. We're going to take a look underneath here and see what gets warm. I suspect it's going to be the IC, but I guess we'll find out. Aha. And going away. See if there's anything on any other part of the board. Nope. Just that IC right here in the center is what's getting hot. And I cannot seem to find a data sheet or an exact part-for-part replacement without having to go to potentially eBay or Alibaba and or order a part from China, which I don't like to do. So I'm gonna have a good mull over on this. And again, if this right here is blown, and let's say I do get the part and replace it, is that going to fix the entire receiver? I still do not know. At this point, I'm believing this is bad, because it makes no sense for this PMIC to be shorted out between that post and ground, especially when we have other PMICs on the board like this one that where was it at? That one and this one over here, which is basically, this one over here is the same arrangement and those pins are not shorted. So what to do, what to do, what to do? I'm gonna have to give this a good thought. And then after I give it a good thought, I'll come back and let you know what I decide. So here's the deal. You can buy one of these outright through part suppliers, and I believe they come in from China or Australia, one or the two from what I researched, for about $150. You could get the IC itself somewhere in the neighborhood of $10 to $20, but that's going to come in from China. Okay, now in a bit of online sleuthing I did, various forums, I happened to stumble across a forum that said that this does a handshake with another IC, probably one that's close by, one of these over here, maybe like that one, or maybe it does a handshake with something else. But to basically check to make sure it sounded like, as from what I read, or it read like, they have to be a matched pair. So you have to potentially do some programming on the chip before you can insert it into the board. So I look at that and I go, well, I don't want to risk getting an IC. Okay, it seems like, unless I can get it from a reputable supplier, whether or not it has to be programmed, there's too much risk there. So the next question is, well, should I buy this board outright? And that answer is no, because you can get a used working Sony receiver, STR-DH590 or whatever this is, for roughly working for roughly like $160 on eBay, give or take $20 in either direction. Okay, so why would I pay $150 if a new one, or sorry, a used one, is going to be around the same price, right? Just doesn't make any sense. Okay, now you can get a few broken ones off of eBay for around $60 to $80. Now that might make sense and you can make a little bit of profit on there. I haven't fully decided if I'm going to do that yet. Last thing, a new one in the box is around $230 or $250. So depending on where you get it. So you'd be better off buying used, and then you'd be better off buying a broken one of these, barring if the same parts aren't broken in it, in order to repair. Now, like I mentioned, I don't know if this is the only problem. I suspect this is the problem. But we can do some other checks as well, just to test our amplifier section. And really, on these Sony receivers, they haven't really changed much since they're the analog versus moving over to the digital format with HDMI inputs and going away from composite video. Okay, and basically you pretty much have the same setup for a 5.1 receiver system. You have two transistors, a per channel. That's these guys sitting right here. Actually, let me come down. Those guys sitting right back here. Okay, one is a MN2488, which is an NPN transistor, and another one is a MP1620, which is a PNP transistor. Okay, and then the pin out's all the same: base, collector, emitter, with base being the first pin, collector, middle pin, emitter, third pin. Okay, and then following the emitter, you have these emitter resistors. Okay, so each channel is driven by 2 transistors, and the emitter is tied to this emitter resistor per each channel. So we can at least test these and potentially make some determinations. You know, again, this isn't going to test the relays, although I did hear some clicking. So that tells me that the relays are potentially fine. But we can at least check this stuff down here and, for the most part, eliminate the actual amplifier section, because it will definitely be in definitely remain in overprotection if you have an issue in that amplifier section. But like I said, we're missing that 2.2 HDMI voltage. Whether or not it has to be fed to this board with these missing components, I don't know. My assumption is, you know, it needs to at least be on this board right here and detected in order for the system to operate. Sans while we have a short on this PMIC, and while we have a hot spot on the IC that's potentially causing that. Okay, so we need to, the first thing that we can do is we can check these emitter resistors, okay, and they're going to be low resistance. All right, you can see right there on my volt ohm meter, again 0.2 resistance just on my leads, but we'll go from outside to middle on each one, and they should all be around the same. So we got 0.4, 0.4, 0.4, looks like we're going to have 0.4 all the way down. So as of right now, these emitter resistors appear to me to be perfectly fine. Next thing I'm going to do is put this into a diode check. I'm going to put these slightly longer leads, these needle point leads, onto my volt ohm meter leads, my multimeter leads, and we can start with our not pointing in. I mean, we need a positive on the base. And that's what I would suspect on the 2488 from base to collector. And we'll go base to emitter. Yeah, 0.6 voltage drop. We'll check all of them exactly the same. Yeah, 0.6. Alright, and now I'm going to reverse the leads and put the negative on the base and check base to collector and base to emitter as well. And we should have something akin to an open, but yeah, because it's in circuit, it's not going to be fully open. You can see it's counting up right there. Either way, there should be no short. Alright, so see it count up from 1.9 and then base to emitter. Come on. 1.4, and it's just hanging there. Alright, so we'll do the same thing for the rest of these. Yeah, 1.9 and counting. 1.4. 1.9 and counting. 1.4. 1.9 and counting, 1.4, 1.9 and counting, 1.4. All right, now we need to do the same for the P and Ps. So that means that we need a negative lead on our base, and we'll check base to collector, base to emitter. Should get a diode reading. We do. 0.6. 0.6 voltage drop. 0.6. 0.6. 0.6. 0.6. 0.6. 0.6. 0.6. 0.6. Okay, and then I'm going to reverse the leads. Again, it should read like an open, but because it's in circuit, it's not going to necessarily be open. So probably like a 1.9 and counting again. Yeah, 1.4. 1.9, 1.8 and counting. That will go over 1.9, surely it will. Slightly lower on this one, but 1.4 nonetheless. Yeah. 1.4. 1.4. Now that one is quite a bit lower. Let me get this back on here. Yeah, this very last one. It is counting up though. So let me check this. 1.4. All right. So nothing that's really too concerning. Okay. So the last thing I'm going to do is I'm going to get the that HDMI card, video processing board, back into here, and everything kind of hooked up. And then we're going to do one last measurement on our emitter resistors. Alright, so I've got everything back together, and to answer a question that you might not even be asking, why did I go through the hassle of putting the board in, putting all the screws back in and getting it all back in and screwed to the chassis versus laying in here? Well, the chassis is meant to be a part of the ground plane, okay? And so if I am going to use the chassis to make measurements and use the chassis as for my ground probe, as you see right down there, then I want to ensure that everything that should be tied to the chassis ground is in fact part of the chassis ground. Otherwise I could get erroneous readings. And that's basically all there is to it. So say this was removed and not touching the chassis, I'd be fully dependent on one of these lines being a ground, okay? But I potentially wouldn't be able to go from the chassis to on here to make a measurement. I would, if it wasn't tied to the chassis, I'd have to go to a ground somewhere on here to make a measurement because it wouldn't be a part of the same circuit at that point. But anyways, what we're going to do, I got my voltmeter set to DC. We're going to power this on, and I'm just going to check the center pin for a DC voltage on each of these emitter resistors, and we're going to see what we get. And this will be our last check. Now for the time being, I've got this back on my behind my variac and dim bulb tester. do have a red light, and I'm just going to turn it on. Low DC here, low DC here, that's all good. Low DC here, low DC here, low DC there. So if any one of those was looking a bit different, say if we had high DC on any of these center pins, then we would definitively have a problem in our amplifier section. And I do have a few other things that we could just check really quick. So if you follow this lead down, you'll find out that pin 1 is going to be your standby 10 volts, which we have. Pin 2 will be ground. Pin 3 will be AC cut. Nothing there currently. And then pin 4 is our power RY, maybe for the relays. Not too sure. But we'll turn them on and check it again. I imagine the first one, the voltage will drop once it's on. Yeah, we go from 10 to 7. Of course, that's a ground. Not sure what the AC cut is, but nothing there. 3.1, yeah, for your relays. Okay, yeah, it just shut itself back off. And then we can also check our B minus. Let's turn it on. Should be around 50 volts. And it is 51, negative 51 for our B minus. And then we could check our B plus. And we get 51 volts there. So all that looks good. I would suspect if we had bad transistors on that center pin, you'd probably see that B minus or B plus. So yeah, I think the amplifier section is good. I don't think it's bad. I think this strictly pertains to the HDMI board, and that's what needs to get resolved in order to bring the system back to life. Quick side note, because I don't like to come off misleading in my videos when I speak, and I work on things and forget certain things, and I often don't use schematics and diagrams, but it appears where that HDMI 2.1 voltage should be developed at, that's for the H79 models only. So that explains why that's missing from this pin. And but we still have a problem with this board regardless. AC cutoff, what that actually is some kind of AC cutout detect. And then the RY does represent relay, and that 3.1 volts, 3.2, whatever we saw there, that is the power to energize our relays. So just felt like I should add that in, giving my waffling on what those pins represented. Well, for the sake of proving the fault, what I went ahead and done is got a broken one off of eBay. I think the seller was asking for like 60 plus shipping. I offered 50, and the seller agreed. And so I've got another RCA sitting right here. Now, as far as what the seller identified is, it does power on, but then after a while, and works, but then after a while goes into protection mode. So hopefully it's not the same issue. We'll get this out of the box, take a look at it. This one is a tad bit worse for wear. I don't know if this was damaged in shipping or whatnot, but yeah, obviously a very well used Sony receiver. So But outside of some cosmetic issues, everything else appears to be okay. I can get the cover off. I'll get that board removed, and we'll just quickly diode check the components on the bottom of the board and swap it out, see if that resolves our issue. Pull this board out. Here goes the other side, which you can see that PMIC and those two capacitors, what were essentially the problems in the other board. Oh, those weren't, but the IC had a short in it, which was causing a short on this side over here. But we'll go through the entire thing. So 0.6 voltage drop on that cap. Center for both should be ground. And then we have a 0.4 voltage drop on the other side. So at first glance, this appears like we have proven the fault, at least a fault, in the previous Sony receiver. So I'm going to get this into our first broken one, and we'll power it up and see how it does. Okay, time to do that first power up post repair. And I've got a red light. Let's turn it on. Well, sounds like we've got a bad relay in here as well. So it went into protect mode. So we actually have two issues. I'll try to cycle this one more time. Well, actually, to confirm that it's a relay issue and it's not the fact that I had it on my dim bulb tester, I moved the plug off the dim bulb tester out from behind the variac and just put it on the isolation transformer, and we'll try it one more time. Yeah, still going into protect. That's perfectly fine. But at least now we know that we had multiple issues with this one. I wonder if I was to now put this on DC and just measure our different transistors, if we're going to get a different reading than before. 0, 0. I think we just shut back off. 0. Oh, now we shut off. Try it one more time. 0, 0. Wait a second, is it on now? Seems to be on and staying on. Wonder if those relays were just cold and they needed some time to warm up. I have had this sitting out in a shed that is not climate controlled. So those relays could have been just very cold. Yeah, I'm not seeing anything bad on those emitter resistors, and it is now on. on. Let me see if I can get my phone paired to it, get some audio through it. We'll be right back. Well, currently am feeding a 1 kHz tone into here, and we're getting 6.24 volts on the front right channel. Let's check out the left channel. 6.8. Let's check out our center channel. 4.96. So you're probably going to see some amplitude differentiation because of the settings on the speaker. I'd have to get the remote. I'm pretty sure some are set at a higher dB level than the others, because your front speakers are facing you, so you don't need them to be a very high level. But we'll confirm with the surround sound because they typically sit further away. A lot of people, yeah, ouch. Let me increase that by 1. Typically those are set higher by a lot of people. So yeah, we're seeing 20 there and 20 on the other one. And kind of just want to check some linearity on every single one of these speakers. Give me a second to get my probe put in a little bit better. Alright, so here goes surround left. And we'll turn off volume pot. It's actually controlling the volume on my phone. Interesting. Didn't suspect that it would do that. Anyways, that's a nice sine wave. I mean, we've got just a smidge distortion in our peak here, but that could also just be my O-scope. Let me actually span this out. Yeah, it's probably just the O-scope. I'm not seeing any issues there on the left. Surround left, I'm going to go through and look at surround right, center, and front right and left, and just check out the linearity on it as well. And yeah, confirming with the amp menu, front left set to 0 dB, front right 0 dB, center channel -2, that's why it was a little bit lower, surround left +10, surround right +10. We're going to lower these all down to 0. That will be our baseline. Then up, nope, not tone. Yep, 0, 0, 0. 0, 0. Now I'm just going to go through and Bluetooth. I'm just going to go through and recheck them all again. Okay, and let's see, front right 3 volts, front left right around 3 volts, 2.98. That's not too far off. Certainly within a margin of error. 3.08 on the center. 3.14 on our surround right, and 3.16 on surround left. So yeah, they're all with pretty close to right there to 3 volts. Now all that's been reset. So confirmed that. So there's definitely no amplifier issue as far as difference in amplitude, because it was the settings right there on the front. So fair enough. Okay. I suppose I can button this guy up, and the ultimate test is going to be hooking it to the TV and make sure the HDMI and everything works. And you know, then I'm going to have to see if I can flip this and sell it. I have to recoup what I spent on this other receiver down here, and you know, I maybe stand to gain if I'm lucky like 40 or 60 bucks on a sell on this, but we'll see. I figured, why not satisfy the internet, even though I believe it's this, and pretty much positive it's going to be that. Why not just go ahead and remove this IC and confirm it? So I've got a bit of rosin flux around it, and I'm just going to use my hot air gun. We're going to heat it up and we'll remove it from the board, and then check those caps, would be this side and this side, to see if that short is removed, or those shorts, whatever. Let's go to the diode check, and let's see if we can confirm my suspicions, which I believe we will. Okay. And yes, we have. %, that chip. Let's look around on the back. Go to the back, and black probe on ground again. Okay. Yep, 100%. That IC right here was bad, and we've proven that. So there you have it. Well, here we go. I've got everything moved over from this Onkyo receiver, and the back's not even powered up. So, and we are getting video. Center channel speaker audio, right channel speaker audio, left channel speaker audio, surround left channel speaker audio working, and surround right channel speaker audio working. Let me switch it over to TV. Let's see. There we go, TV. I need to change the input to.
I wish I could jump these buses by.
Yeah, probably need to swap the TV input over. It's in a cable.
Funding for Almost has been
There we go.
provided in part by
A child's imagination propels big dreams. PNC Grow Up Grade is here to help young children learn with resources in English and Spanish, because early childhood education is the way to reach the stars.
and by the Corporation for Public Broadcasting, a private corporation funded by the American people.
All working good. So I'm happy with that. Well, if you've enjoyed this repair video, please let me know by leaving a comment in the comment section. If you're new to this channel, having first been here, consider subscribing. Everybody consider giving this video a thumbs up. Again, I still offer repair services. You can email me. Description is all there on YouTube, contact information, Google site, all that kind of stuff. But anyhow, that's going to do it for this repair. Thank you for watching. Take care and goodbye. Bark.